Join the conversation.
Join the conversation.
You're with Cape Talk.
And now for that much anticipated interaction with the naked scientist, consultant virologist at Addenbrooke's Hospital in Cambridge, Dr. Chris Smith. Joins us on air to answer your questions, science, maybe medical related questions. Keep them coming through via WhatsApp 072 567 1567. Or better still, jump the queue and give us a call on 021 446 0567 at 9:35. Welcome, Dr. Chris Smith.
Morning, Clarence. And I'm turning up for class with my homework done. Do you remember? Well, you weren't here last week because Saskia was here last week, but we had a really interesting point.
From you.
Someone rang in and said, well, do animals have colour blindness like people do? Because we'd been talking about colour blindness in the context of the football, because not all colours for the crowd are easy to discern against the pitch. Not all colours of other players are easy for some players to discern. And so this had got us talking about this at the Naked Scientists, and then someone just happened to phone in and said, well, do animals have colour blindness? And I was intrigued, and I speculated that almost certainly they do. And I don't just mean the fact that some animals see fewer colours than we can discern as humans. I was actually, and I think the questioner was referring specifically to the fact that there are people in our population who, for genetic reasons, struggle to discriminate between certain colours. Does the same apply to animals? And I said, well, I'm sure it will. And I went and did some digging, having made that speculation last week, and the answer is yes. You do find animals that, in the same way that genetically we have genes that mean that we are unable to discern certain colours and tell them apart from each other, there are equivalents in animals. Some monkey species, for example, particularly the males, in the same way that we have human colour blindness that's affecting males, not females, because it's on the X chromosome, the gene that's affected. Same thing happens in some primate species and other animals as well. So the answer to the homework is yes, animals do get colour blindness in the same way that we do, over and above their ability to use the repertoire of different photopigments in their eyes to tell different colours apart.
Fascinating. Now, the first question is around the hair-raising experience when we get a fright. Why does that happen, and does our hair actually rise in the process? From Keith.
Hello, Keith. The answer is yes, it does. And the process of hair standing on end is called erection, from pilus in Latin, which means a hair or thread, and erection as in stand up or put up. And the reason it happens is that connected to the base of each hair is a tiny muscle, a piloerector muscle. And this is wired up to your sympathetic nervous system. The sympathetic nervous system is part of your autonomic or automatic nervous system that's concerned with the fight or flight reaction. Anything that's a stress for the body activates your sympathetic nervous system, and therefore one of its outputs will be to make your hair stand on end. Why do we have this? Well, in animals, which are a lot more hairy than we are, one of their techniques when threatened to make themselves look bigger and scarier is to make their hair stand on end. Because if your hair stands on end, A, it's an alarm signal, but B, it makes you bigger because your hair standing up takes up a lot more space than your hair laying flat. And if you look bigger, you're more likely to scare off an opponent. Now, we've inherited exactly the same traits. We're a lot less hairy than some animals, but we still have those hairs, we still have piloerector muscles, and therefore we still have the ability to make them stand on end. The other mechanism when this is invoked is to keep us warm. And animals do this to great effect. They puff their coat up because they trap a layer of air in their hair, and air is a very poor conductor of heat. And therefore, if you make your hair stand on end, you increase your air insulation and you conserve heat better. And we, again, have inherited this from our hairier days and hung on to it. So when we are cold, we also make our hair stand on end. And when do you see that? Or how does that manifest? Well, you see the bumps of the muscles contracting, goose pimples or goosebumps. And that's the bulge made when the muscle that would normally or does make the hair stand on end gets shorter and fatter. And this is why your skin goes all prickly when you're cold. It's your hair standing on end and making goosebumps, and they're all linked together.
We've got a voice note. Before we go there, it is a cat question. There is another cat question in. How exactly does a cat purr? How does the cat create that continuous low-frequency sound without running out of breath? And then Wesley's got this question in about cats as well.
Good morning. If I'm not mistaken, I could be wrong,
But I was watching a documentary on how cats see color and how they see things, and it's on certain spectrums that they see colors, and it's not all the colors that we see, but on the I think it's more of a blue green that they see, if I'm not mistaken, and it's actually fascinating what if it's true that they can see like this because that spectrum tends to make other things, more visible rather than if it were in full color.
This sort of goes back to the point we were discussing at the top of the programme, which is colour blindness or colour perception. Now, in our eyes, we have in the retina, which is the light-sensitive sheet at the back of the eye, photoreceptors, rods and cones. And the cones, C for cone, C for colour. The cones are the ones that have different pigments in them that can see colours. So the way this works is you have chemicals called rhodopsins, which are in the cones, and different recipes for rhodopsins enable them to respond best to different coloured lights. And we have, broadly speaking, 3 different cone populations: those that respond best at the red end of the light spectrum, those that respond in the middle or green part of the spectrum, and those that respond best at the blue end of the spectrum. So when we shine a light into someone's eye, just by looking at something, you will have a combination of colours which will therefore switch on to different extents, different combinations of those cones. And the brain can interpret based on how much the red is being stimulated, how much the green is being stimulated, how much the blue is being stimulated, what the colour, in inverted commas, of the thing you're looking at is. Now, in a colourblind person, they may not be able to make, for genetic reasons, one of the rhodopsin types. And the most common is the rhodopsin type at the red end of or green end of the spectrum. So, as a result, your cones respond equivalently to light that's either red or green. And so, therefore, if you respond the same to both colours, as far as your brain is concerned, you must be seeing the same colour. So a person who is colourblind is therefore seeing the same colour when they look at different colours, which is why you can't discriminate those things apart. Now, in some animals, they don't have 3 different cones like this. They have fewer. They have just 2. And this narrows the different combination of colours that they are able to discern. Dogs are like this. Cows are like this. Horses are like this, for example. So it doesn't mean they can't see, doesn't mean they haven't got quite good vision, but the colour discrimination is weaker. Other animals, on the other hand, are at the opposite end of the spectrum. They've got more of these different cone types with more different rhodopsin chemicals, so they can actually discriminate much broader ranges of colour. There are some animals that will see ultraviolet. That's completely invisible to us, but animals like bees, for example, they have pigments capable of seeing ultraviolet, and that turns out to be really important so they can navigate, because even on a cloudy day where they're using the sun as a compass to drive their flying direction, they can still see the sun through its ultraviolet coming through the cloud, so they can always navigate. So some animals have more pigments, therefore see more colours, some fewer. And it's what they've evolved to do best. And so an animal always evolves to fit its niche in the environment. It's very costly running a brain, it's very costly running vision, and nature doesn't like waste. And so nature will evolve a system which achieves the best outcome for the least spend on the energy and on the complexity, because the more complex it is, more likely it is to go wrong. Now, on purring, we used to think that cats just vibrated their vocal cords because there was a part of the brainstem called a neural oscillator, and this is effectively a rhythm generator in their brainstem, which makes them vibrate their vocal cords at the purring rate, which is about 100 hertz or so, I think it is. Now, we also now know from other studies, because people have done careful anatomy studies, that there are also some changes to the vocal cords in cats. I think they have some fatty material around the vocal cords, which makes it easier for them to sustain that purring sound. So I think it's a combination of they have specific neurological wiring to make the sound, and they have anatomy that also helps them to sustain the sound.
Let's go on to Caroline's question. Good morning, Dr. Chris. I have this constant ringing in my ears. I know it's tinnitus. It's not from listening to loud music, but I am on an antidepressant, Life. Could that be what's causing it? It's really debilitating having this constant ringing. How is it treated?
Hi, Caroline. Sorry to hear about your symptoms. The first thing that you always consider when someone says, well, could a drug be causing this as a side effect? The first thing to say is, well, any drug can do anything to anybody because there are so-called idiosyncratic reactions. We're all different. There's no person, unless you have an identical twin, who shares your genetic makeup. Therefore, we are all individual, and drugs can affect all of us differently. So if you have a symptom and you're on a drug, of course they could be connected, but the question becomes, well, how likely is that? Now, if you never had this problem, you started taking this drug, and then almost immediately, or in a very short space of time after you started taking the drug, you started getting the symptom, this doesn't mean it absolutely is connected, but it would make a doctor very suspicious that the two might be connected. Is there a plausible biology for why they might be connected? Yes, there is, because what these drugs do, when they elevate mood, they're targeting various neurotransmitter systems and pathways in the brain, and they are shifting brain chemistry towards a greater degree of mood stability and an overall improved mood. Well, if you're changing neurochemistry and the way that nerve cells talk to each other, it's perfectly plausible that one side effect of that could be that it affects the way that other organs work and how systems interpret different stimuli. So that's definitely plausible. Can they affect the ears? Well, possibly, because these drugs also have side effects outside the nervous system. They have so-called antimuscarinic side effects outside the brain, and these can include effects on sex, effects on urination, effects on eyes and mouth, dry eyes, dry mouth, some of them. And some people do say, because the fluid in the ear, that's how the cochlea works, is produced in response to signals in the nervous system, they could be disrupted too. So it is possible that this is one side effect that is happening because of the agent. On the other hand, tinnitus is very common. About 1 person in 5 has this at any moment in time, and the biggest risk factor is age. So as we get older, we're more likely to have this happen to us. And so it is also possible that there is a coincidence here. The tinnitus is not connected to the drug. But as I say, the big giveaway for me when you ask a patient is always, did you start the drug and then the side effects started? If you'd had the problem before you went anywhere near that drug, it's almost certain the two are not connected.
Our guest, the Naked Scientist, every Friday at 9:30, and you can put your question via WhatsApp on 072 567 1567, or you can jump the queue on 021 446 0567. That's the number that Mike called. Good morning, Mike.
Hi, good morning, Doctor. Just a question regarding inoculation for young kids. I'm on the wrong side of 70, but my kids are all having babies now, and they're very against inoculating for smallpox, chickenpox, mumps, measles, polio, etc. They say it's all a throwback from what happened during COVID, so they're against pumping any serums into their kids' bodies.
And is there a question connected to that, Mike?
Is the valid reason not to inoculate your kids? I think you're just putting them at risk.
Well, the epidemiology, in other words, if we look at the world population and we look at health outcomes, the evidence strongly favours vaccines being a very good thing. We used to have hundreds of thousands of people in individual countries being paralysed by polio every year. Now that number is down to less than 10 in the entire world, and we've almost eradicated polio. From people being paralysed and condemned to spending their lives in an iron lung to breathe for them, including the famous case of the American lawyer who died recently, who spent his entire life practicing as a lawyer from inside an iron lung because of a virus he contracted as a child. Meningitis kills enormous numbers of children every single year. We in the UK have had a couple of outbreaks just this year of meningitis B among younger people in their 20s and late teens, and the number of cases and the number of people who've died has increased appreciably. This is all preventable with vaccines. And before we were vaccinating against these things, many, many more people died. So the evidence we have is that vaccines are an incredibly powerful thing. They're an incredibly good thing, and they are saving millions of lives around the world. That doesn't mean that they're not without side effects, because all drugs and all treatments have side effects, but they are all trialled rigorously so that we are comfortable that the risk, if any, is massively outweighed by the risk of the disease itself. We never give treatments where the treatment is worse than the disease, because that's unethical and it's a waste of money. So the amount that gets spent on vaccines is justified because we know, based on the figures, that people are much better off having the vaccine than not having the vaccine. And you're right to point to COVID, because unfortunately during that period enormous amounts of misinformation circulated, and we've ended up smearing a very successful health intervention which has saved millions of lives over the years. And unfortunately, because of bad publicity around the pandemic and people being very susceptible to misinformation at that time for all kinds of reasons. But the evidence is we spend a lot of money helping to vaccinate people and saving a lot of lives because we have the evidence that it's a very effective way to keep people healthy. And if you look at the average graveyard from 100 years ago and tot up the number of graves from people under the age of 5 and then compare that to today, you can see that the burden of infectious disease in young people is tiny compared to what it once was. And a significant contribution is because we vaccinate against some of the dread diseases that used to claim enormous numbers of lives.
We've got a message in via WhatsApp. Let's take a listen to Jennifer's message, Joe.
Good morning. It's Jenny and Obs. If you want to have a really good example of piloerection, go and Google dominance behavior of Nyala males. Nyala, Nyala males. It's absolutely spectacular. They do a dominance thing where go and have a look. It's actually worth watching.
Thanks for that. Let's go to Finlay's message as well.
Good morning. Just a thought. Perhaps the doctor can give an answer. As I say, purely a thought. When we're born, we can all see objects, space, plants, trees, etc. As babies, we all see the same. But if looking at your parents and school, obviously pre-primary school and that, you get taught that is red and that is green and that is blue and so on. So I was just thinking that when we're born, we can all see the items, but to identify the color is something that we've been taught as children. And then obviously as we grow up, we learn the variations in colors. Could that be a correct theory?
Yeah, and it's a really important sort of philosophical point, which is that we all learn all this stuff, but we have no idea if, when I look at, looking at Clarence's face right now, ouch, and I have no idea if, let's take his glasses, which are black with a blue bit on the side. Well, does he, when he looks at his glasses in the mirror, does he see the same colour or colours and say, well, those are black glasses with a blue bit on the side? Is his brain experience the same as mine? We have no idea whether my perception of blue is the same as his or yours. We agree on that because we've been told, yeah, that's blue. But we basically have an assemblage of nerve cells in the back of our heads, which we call our visual cortex, which all fire off when different signals go into our eyes, and they fire off when signals of certain colours go off, and then we are told that experience you're having is blue, or that experience is a red sunset. But is the way my brain is seeing that, is the experience I'm having the same as yours? We have absolutely no idea, because all we can do is watch the brain in action as an electrical organ, but we can't take the experience that my brain created and put it into your head and say, was that what you saw? We just have to hope that because our brains are broadly wired up the same way and they broadly work the same way, we're all individuals, but our brains are largely similar in how they work, that what I'm seeing and my experience is probably the same as yours, but we can't know for sure.
Message in from Brian. Great show. As always, please play that clip of the naked scientist speaking about the success of medicine, vaccines, every day. And then this voice note in from Neil. Let's take a listen, Joe.
Good morning, Clarence. I've got a question for a naked scientist. I'd like to know what his personal opinion is on what he thinks happens to us after we die. Thanks, Neil here.
Oh, hi, Neil. Well, there's two aspects to this. There's the spiritual aspect, and then there's the scientific consideration. So let's separate those two, because there's nothing about religion that can't be an easy bedfellow with science, because they're two totally different things and they shouldn't be conflated. So let's put the spiritual side to one side, and we're not putting any kind of aspersions on that. If people believe that their life ends, that's up to them. If people believe that they come back as a cabbage, that's up to them. If people believe that they come back as another person or whatever, that's up to them. From a scientific point of view, we're alive because we are a big combination or collection of cells that work as a community, and some of those cells create a brain, and that brain creates an experience of being alive and a consciousness and a sense of time passing and a memory of what's gone in the past and what will come in the future. And all this is powered by a heart and lungs that bring oxygen and sugar to keep that brain alive, and other organs that keep those other organs healthy and happy, so that the whole thing carries on. We're basically a life support machine for a brain. And when the life support machine for the brain expires through whatever reason, usually because we get old, things begin to clap out, and eventually they clap out beyond the ability of other organs to compensate, then the life support machine turns off. This means that the assemblage of cells in the brain creating our life experience turns off, and therefore for us, life ends. And we are basically a big bag of cells that then turn into a big bag of molecules and juices that other organisms, usually bacteria, fungi, invade and then recycle. So in the grand scheme of things, we're just a big bag of chemical reactions that happens to have the ability to interpret our surroundings and respond to them and respond to each other for a short period of time that we're alive on Earth. And then we return all of our molecules back to Mother Nature, who turns them into another living thing somewhere else.
Let's try and squeeze in this question from Andre. Dr. Chris, what do you call the condition where people can't recognize faces?
It's called prosopagnosia. And this is reasonably common. I know a couple of people with this, and it's thought to be due to an issue in your superior temporal gyrus, which is the part of the brain, the temporal lobe, the upper part of the temporal lobe. There is a specific region there which decodes faces. So if you show pictures of faces to a person in the brain scanner, that part of the brain lights up like a beacon. And in some people, for some reason, possibly miswiring, then they can be shown the same face multiple times. They won't recognise it. They don't even recognise their own children until they open their mouth and start talking. And then they recognise the voice. Oh, yeah. And it's face blindness in the same way that a dyslexic is word blind to certain words, certain word combinations, or struggles, really has to concentrate hard to decode the meanings and the connections of words and read a sentence if they've got severe dyslexia. A person who's face blind has exactly the same thing with faces, and they walk down the street and they'll see people they know, but they don't know they know them until they start talking to them and have other cues to help them to identify that person.
And we'll have to rest it there. And a big thank you, as always, the Naked Scientist, Dr. Chris Smith, consultant virologist at Addenbrooke's Hospital in Cambridge, every Friday at 9:30, right here on Views and News.